You know that picture of Jupiter we all have in our heads? The beautiful, striped giant with that famous great red spot. For the longest time, we thought we had it pretty much figured out. A gas giant with a nice, small, solid core. Simple. But since 2016, NASA's Juno spacecraft has been looping around Jupiter, and wow, it's been peeling back those cloudy layers to reveal a planet that is just so much weirder and more complex than we ever imagined.
And that was the whole point, right? To answer this one huge question. Juno was sent on this incredible journey to really probe Jupiter's depths, to measure its gravity, and to map its insides in a way no one had ever done before. And let me tell you, the answers it sent back didn't just add a few new facts to the textbooks, they pretty much blew them up.
So, here's what we're going to cover. We're going to unpack 5 of the most mind-blowing discoveries from Juno. We'll start with what's hiding deep inside the planet, then dig into this mystery of its fuzzy core, and check out a wild theory about how it got that way. Then we'll look up into its crazy atmosphere to talk about something called mushballs. And finally, we'll zoom out and see how all this adds up to a whole new Jupiter. Okay, let's start with the biggest shocker of them all, the one that basically forced scientists to throw out the old models. And it all has to do with what's at the very heart of the planet. See, the old model was so clean. You had this huge envelope of gas, and right in the middle, a compact little ball of rock and ice. But Juno's gravity data, it painted a completely different picture. There's no distinct core, no sharp boundary. Instead, Jupiter has what scientists are calling a massive, dilute, or fuzzy core. The heavy stuff is all mixed in with the gas, spread out across a huge chunk of the planet's interior. This was the first major clue that we were dealing with a completely different kind of beast.
So naturally, this fuzzy core became the central mystery. I mean, what on Jupiter could possibly create a structure like that? It's kind of like finding out the yolk of an egg got scrambled and mixed through half the egg white before you even cracked the shell. It just doesn't make sense. And just to be clear, we're not talking about a little bit of blurring around the edges. Juno's data says these heavy elements, the rock and ice that should have sunk straight to the middle, are actually mixed across almost half of Jupiter's entire radius. That is enormous. Which left scientists with one burning question. How in the universe did this happen? For a long time, the leading theory was something incredibly violent, a story of pure cosmic catastrophe.
Yep, the idea was that early in its life, Jupiter wasn't just sitting there forming peacefully. No, it was the victim of a truly epic, planet-shattering impact.
Picture this, a massive baby planet, maybe 10 times bigger than Earth, comes screaming through the early solar system and slams head-on into a young Jupiter. The thinking was that this impact was so ridiculously powerful that it would have just shattered Jupiter's original core, dredging up all that rock and ice and mixing it deep into the hydrogen atmosphere, creating the fuzzy core we see today. And look, this wasn't some fringe idea. It was a really compelling, dramatic story that seemed to fit the evidence we had. For years, it was pretty much the leading explanation for Jupiter's bizarre interior. But, you know, that's the great thing about science. You always have to test your theories.
And this is where the plot takes a major twist. Researchers decided to really put this giant impact theory to the test. They ran these incredibly detailed simulations on supercomputers, modeling these cosmic smash-ups. And what they found, well, it completely changed the story. This quote from Dr. Thomas Sandness, one of the lead researchers, just sums it up perfectly. Yeah, an impact like that absolutely shakes a planet to its core. But the simulation showed it doesn't create a stable fuzzy core, not in the right way.
The computer models found some pretty fatal flaws in the idea. First, even after a huge impact, that heavy core material sinks back down to the center way faster than you'd think. It doesn't stay mixed. Second, the simulations almost never ever ended up with a stable fuzzy core like the one Juno actually sees. And maybe most importantly, these perfect head-on collisions are incredibly rare. It's way more likely to be a glancing blow, and those are even worse at scrambling a planet's insides.
So the big takeaway here is that Jupiter's weird core wasn't made in a catastrophe. It was probably just born that way. The new thinking is that as Jupiter was forming, it was gobbling up gas and chunks of rock and ice all at the same time, creating this gradually mixed up interior right from the very beginning. Okay, so as if a fuzzy core wasn't strange enough, Juno found another absolutely wild mystery. This time, way higher up in Jupiter's atmosphere. We're talking about some very weird weather.
So Juno's instruments are sniffing the atmosphere, and they notice that ammonia gas, which should be pretty evenly mixed everywhere, is just gone from these huge regions. It It was like something was actively scrubbing the ammonia out of the upper clouds. And the explanation scientists came up with sounds like it's straight out of a sci-fi novel.
Meet the mushball. Yep, you heard that right. Not hailstones, mushballs. They are literally what they sound like. Giant, slushy, softball-sized hailstones made of an ammonia-water mix, all wrapped up in a hard shell of water ice.
So here's the play-by-play. Massive thunderstorms churn up water ice crystals, carrying them high into the atmosphere. Up there, the ammonia gas acts like antifreeze, melting the ice and creating this slushy, gooey core. As this mushball gets tossed around in the storm, it just gets bigger and bigger until it's too heavy to stay up, and then it plunges deep down into Jupiter, taking all that missing ammonia with it. So yeah, it is literally raining ammonia mushballs inside Jupiter's clouds. Wild.
The thing is, the fuzzy core and the mushballs aren't just a couple of weird isolated facts. The bigger picture from Juno is that pretty much everything we thought we knew about Jupiter needed a serious reality check.
This isn't about just filling in a few blank spots in our knowledge. This is a total paradigm shift. Let's just run through a couple more quick-fire discoveries that show you just how different the real Jupiter is from the one we thought we knew. For instance, the Great Red Spot, that iconic storm that's bigger than our entire planet, it's not just a surface feature. Juno found that its roots go down about 300 kilometers. To put that in perspective, that's 50 to 100 times deeper than Earth's oceans.
And as deep as that sounds, it's nothing compared to the jet streams, those famous bands and belts we see. They extend a mind-boggling 3,000 kilometers down. This weather layer is so massive, it contains about 1% of Jupiter's entire mass. That's like the mass of 3 Earths just in the weather.
And then at the poles, Juno saw something nobody expected: stable geometric patterns of giant cyclones. At the North Pole, there are 8 massive storms, each about the size of Australia, just locked in this permanent formation around a central storm. It's beautiful, it's bizarre, and it's unlike anything we've seen anywhere else in the solar system.
So all of this really leaves us with one final fascinating thought. The Juno mission proved that the one giant planet we thought we knew best, the one right here in our own backyard, is a place of unbelievable, unexpected complexity. So if we were this wrong about our next-door neighbor, what kind of secrets are the thousands of giant exoplanets orbiting other stars hiding? It really just goes to show, no matter how much we think we know, the universe always has another surprise waiting for us.